Hi, let's build the periodic table from a blank template that you see out here, okay? So if you, the periodic table is basically built based off of atomic numbers, which is the number of protons in the nucleus of an element. So it all starts from the top out here. So that would be one proton, and then you go from left to right. Okay, so you go from left to right, and then when you reach here you wrap around. Okay, so I'll show you how that works. So this is one proton that has two protons, and then you wrap around, which means you go and restart back from here. So that's 3, 4, 5, 6, 7, 8, 9, 10. Again, wrap around and start from here. 11, 12, 13, 14, 15, 16, 17, 18, and then wrap around. Let's pause for a second and take a look at what we just did out here. So these numbers, the number of protons, are the atomic numbers, right? So atomic numbers is equal to number of protons. And what's interesting is since the periodic table is based off of different number of protons, so each of these numbers corresponds to a specific element. So 1 corresponds to hydrogen. I'm going to write that out here. Okay. And hydrogen is denoted by a chemical symbol, which is a capital H. So a quick note about chemical symbols. So that's a chemical symbol. Chemical symbols are either a capitalized letter, it's a single letter, or it is a capital letter plus a small letter or a lowercase. So in this case, I'm going to write that, change the color out here. So hydrogen is, there's a capital H for hydrogen, and then number 2 stands for helium. So that's going to be capital H and a lowercase e. Okay. So why did we choose to do that? Simply because if we chose H for both of them, hydrogen and helium, then we wouldn't know which H stands for who. So we want to differentiate elements that start with the same letter. So using that logic, turns out after helium, on the left we have lithium. And then number 4 is actually beryllium, starting for B, which is expressed as Be. And then you have boron. See the logic out here. Be for beryllium. Boron starts with B as well, so therefore you keep that B as capital B, and then beryllium is a capital B with a small lowercase e. And then number 6 is carbon. And then 7 is nitrogen. 8 is oxygen. 9 is fluorine, and 10 is neon. And then we wrap around, and then 11 out here is sodium. And then, 12 is magnesium. And you can keep going down this way. You can refer to a periodic table to go down this way. But right now, we're just trying to understand how the periodic table is built. So now what we see is two things. Let me use the color. Let me use a maybe an orange. So notice carefully, we go from left to right this way. Actually, let me go this way, from left to right. Okay, so when you go across a row from left to right, that is a period. So as you go across a period, just write that out here, period. Period. Period is the same as a row. Okay, so you go from left to right, you're in a period, and as you go from left to right, the atomic numbers increase, which means the number of protons increase in the nucleus. Now recall, the number of protons are the same as the number of electrons. Therefore, the electrons are increasing as well. So in the case of boron, for example, there are 5 protons and there are 5 electrons. Now, if you go down a group, so use a different color out here. If I choose to go down this group like this, each group is actually a column. So in the periodic table, the columns, they are groups, they're called groups, and the rows are called periods. All right, and the periodic table is built up of increasing atomic numbers. Now, if you go across a period, the atomic numbers increase by 1. And if you go down a group, the atomic numbers do not increase by 1. They actually increase by 8. And then it changes a little bit as you go down, but pretty much it's 8 for the first 3. And then the next one, actually, I'll kind of fill this up so we can take a look at it together. That's 19. And then this one is actually 37. Notice carefully, the jump from 11 to 19 is 8, but the jump from 19 to 37 is 18. Okay, and that's because we have another 10 elements sitting in here. Let's count that: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and we'll discuss that later on, but the point is right now we just need to understand how the periodic table is being built up. I hope that made sense.